Good job. Yesterday, your daily math was a review for your quiz tomorrow. If you watched the video, I told you that. If there were questions that you missed on your daily math yesterday, you need to make sure that you know how to solve those, because you'll see questions like that again tomorrow on your quiz when it counts if you get the answers right or wrong. Okay? So make sure you know how to do those. Make sure you know how to do these as well. But those 15 questions that you had assigned yesterday are going to be the main questions that give you points for your daily math quiz tomorrow. Okay? If you have time later on today and you need to go back and look at how you did yesterday and make sure you know how to do those questions, then you may do that. And then if you have questions, you can come and see me so that we can get those taken care of while I have a chance to help you, okay? So I want you to really make sure that you know how to do those questions. Harper, what did I ask you to do? Thank you. All right, so let's look at today's daily math. The first question asks you which model correctly represents the problem. So we have some fractions in all four options, and we're subtracting each time. What do we have to make sure of? When I add or subtract fractions, what has to be the same before I can add or subtract, Justice? The bottom number, the denominator. And in all of our options, the denominator is the same. It's 12 each time. So now I know that I'm just ready to subtract. Does the bottom number change when I add or subtract? No, only the top. Only the numerator changes. All right, so in option 1, I have 7/12 minus 3/12. If I do 7 minus 3, what do I get, Ansley? I get 4. So my answer would be 4/12. They have 6/12 as the answer, so we know that's not correct. Option 2, we have 9/12 minus 3/12. Owen, what is 9/12 minus 3/12?
6/12.
6/12. So I know that answer is not correct. If we go down to option 3, 9/12 minus 3/12 equals what, Harper?
6/12.
6/12. So that's correct so far. All right. Okay, let's look and make sure that they have the correct things shaded. They started by shading 1, 2, 3, 4, 5, 6, 7, 8, 9 of the 12 pieces. That's correct, isn't it? But they crossed out 1, 2, 3, 4, 5 twelfths. So is the model a correct representation of the problem?
No. That would be 4/12.
Yeah, they didn't cross out the same amount that they showed in the equation. Okay, so on option 4, we have 9/12 minus 3/12 equals 6/12 again. This time we can see that they shaded 9 of the 12 pieces. And how many did they cross out, Olivia?
3.
They crossed out 3/12. So that leaves 6/12 shaded, and that is the correct answer. Looking at just the model here, we know that's 9/12. Can you see an equivalent fraction to that 9/12?
Equivalent fraction to 9/12.
Just by looking at this picture, what do you see, Jacob?
3/4.
3/4. Very good. 9/12 is equivalent to 3/4. And once we take away those 3/12, how much is left shaded?
6/12.
6/12. So what's an equivalent fraction to 6/12?
1/2.
1/2. Very good. Okay. We have another subtraction problem here. This time we have a mixed number. We have 3 1/8 minus 1 3/8. So what should be shaded to begin with, Kaden? How much should they have shaded to begin with? 3 and what? No.
No, 3 and 1/8.
3 and 1/8. So we should have 3 holes shaded and 1/8 more. Jaden, which shows that 3 and 1/8 shaded? Which 2 options?
The second one and
This one? Is that 3 and 1/8?
no.
No. Okay. Does this one have 3 holes and 1/8 shaded? Okay, so option 1 has 3 and 1/8 shaded. Option 2 does not. How about option 3? Does that show 3 and 1/8? Option 4?
No.
No. So I know that my only 2 options are going to be 1 and 3. I can eliminate the other 2 choices because they don't start with the correct amount. I'm taking away 1 hole and 3/8. Does option 1 show 1 hole and 3 of 8 pieces being taken away?
Yes.
Yes, it does. Option 1 is the correct answer. All right. Next we have some angles. And it asks which angle is around or about 135 degrees. So if I'm looking for about 135 degrees, if I look at option 1, remember the little semicircle that's in the middle shows the part of the angle that we're measuring. So I'm starting here. If I go from here to here, how much is that? 90. And then to here is 180. And then a little less than halfway.
Is 50, 40.
Okay, so 180 plus.
70.
Okay, so that's going to be, if I get to 180 and I add about 30 to 40 more.
That'd be 220 to 211.
Okay, so is that going to be about 135 degrees? No, that's too much, isn't it? Okay, so if I come over here to option 2, remember I'm looking again at the arc to see which part I'm measuring. I know this much is 90 degrees. And then I have almost another 90 degrees, so almost 180. Is that about 135?
No.
That's a little too much again. Okay. If I come down here to option 3, I'm looking at the arc. I have one 90-degree angle right here, plus a little bit more. Would that be about 135 degrees?
Yes.
Yeah, option 3 is the correct answer. How do I know option 4 is incorrect?
Because it's way small.
Yeah, it's not even 90 degrees, so I know that can't possibly be the correct answer. Okay, questions about that one? All right, we have a shape next. It asks us to identify the shape. Is it a rhombus, a parallelogram, a trapezoid, or a rectangle, Christopher?
Rhombus.
It is a rhombus. You are correct. Uh-huh.
Was it just number wrong? Because it did like 1, 1, then 2, 3.
No, I put 2 sets of questions together.
On this one, my finger slipped and accidentally pressed parallelogram.
Parallelogram. Why is that not a parallelogram?
Because the sides aren't parallel.
Yeah, the opposite sides have to be parallel for it to be a parallelogram, and those are not parallel.
If you turn it, you can do it this way.
Why is it not a rectangle?
Because it's not. The opposite sides aren't equal.
Opposite sides aren't equal, and it doesn't have...
3 sides.
Do rectangles have 4 sides? 3 sides or 4 sides?
They have 3 sides.
Rectangles?
4 sides.
Rectangles have 4 sides. Jacob already said the opposite sides have to be equal. And one other thing, what about the angles? They all have to be...
They all have to be 90 degrees.
They have to be 90 degrees. Very good. Okay. Let's look at number 4 here. says a bag can hold 8 tennis balls. The factory needs to equally place 835 tennis balls into bags. How many tennis balls will be in the last bag that isn't full? What are we going to have to do to solve that problem? Ainsley, what do we have to do to solve?
835 divided by 8.
Very good. We've got to divide 835 into 8 equal groups or bags of 8. Okay, so if I start by dividing my hundreds place, I always start in the biggest place value when I'm dividing. How many times could I put 8 hundreds into 8 groups? How many would go in each group? How many, Cash? 1. I could put 100 in each group. Do I have any left over? No, I use all 8 of them. Okay, so now I have 3 tens to put into 8 groups. Can I put 3 things into 8 groups? No. So what do I do with those 3 tens? What happens, Olivia?
You put them up to 5 and then you see how much times you can go to 8 with 35.
Very good. So now I have 35 ones. I need to know 8 times what gets me as close to 35 as I can get. Okay. So I could count by 8s. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is... What's 8 times 4? What is it, Cash? 32. Very good. 8 times 5 is...
70. 45. No.
8 times 5.
45. 35. 40.
What is it, Cash?
40.
40. Very good. So can I put 5 in each group? No, I only have 35. That's too much. So I can only put 4 in each group. That means I will use 32 of them. And if I have 35, Harper, how many are left over that won't go into a bag?
6.
If I use 32, because 8 times 4 is 32, and there are 35, then I will have 3 left over. So the question said, how many tennis balls will be in the last bag that isn't full? So what's my answer? 3. I had 3 left over, or 3 remainder. So the answer is 3 tennis balls. Okay. Next, we're looking for the model that represents 5/6 times 2. So I'm going to have 2 groups of 5/6. And I'm multiplying a fraction times a whole number. How would I do that? How do I multiply 5/6 times 2? What do I need to do, Olivia?
You would just add the 5 plus like 2.
No, I'm not adding. I'm multiplying.
5 times 2.
5 times 2, which is 10. So 5/6 times 2 equals 10. And my denominator is still 6. Now I need to make that into a mixed number. If I have 10/6, and I want to make that into a mixed number, how many sixths does it take to make a whole? If there's 6 pieces in one whole, how many? 6. If I take 6/6 out to make a whole, how many do I have left? 4. Very good. So I'm looking for the model that shows 1 and 4/6. I'm sorry, 1 and 4/6 shaded. Which one would that be? Option 4 shows 1 and 4/6. Option 2 also has 1 and 4/6 shaded. But they're taking those 4 away. Very good. From the 4/6 at the bottom. Okay, questions about that first set of questions?
No.
All right, so let's look at the next 5. Okay. This one asks how many lines of symmetry this shape has. At the very beginning of the school year, you did a symmetry project in art. What is symmetry? What is that, Kaden? Yeah, it's where you could split or divide a shape and both sides would be exactly the same. So the line of symmetry shows where that would happen. How many lines of symmetry does this shape have, Kaden?
2.
Tell me where you see a line of symmetry. Like right here?
Yeah.
Okay, so we could split it right down the middle there. If I do that, would it be the same on both sides? Okay. Does anyone see another line of symmetry where it would be exactly the same on both sides?
No.
No, that's the only one. This shape only has one line of symmetry, straight down the middle vertically. Yes, ma'am.
I don't know.
Okay.
Okay. So I see an M when I put a line through it as symmetry as a couple more M's. Line.
I'm confused about what you're saying.
I'm confused about what I said.
Okay. This is the only place. Why could we not make a line going horizontally across the middle?
Because it wouldn't be symmetrical.
Yeah. Look, if I folded, let's visualize folding this bottom half up. Would those meet up? No. That's the only line of symmetry that there is. Okay. Let's look at the next question. All right. 5/10 is equal to how many 100ths? Olivia? 50. So A is going to be equal to 50. Mathematically, I could show that 5/10 is equal to 50 100ths by multiplying what? How would I get from 10 to 100? What would I have to multiply by? 10. 10 times 10 is 100. So if I do that to the denominator, I have to also multiply the numerator or the top number by 10, and that equals 50. So we know A equals 50. For B, I want to show 5/10 as a decimal. How will I show 5/10 as a decimal? What do I do, Olivia?
You would put a 5 in B.
Yeah.
It would be 0.5.
Very good. For B, we would write 0. So I have no holes. Then we would have a decimal point, and we would put a 5 in the 10ths place. For C, we need to write 50 100ths as a decimal. How would I do that, Christopher?
You put a 50 on C.
Well, yeah, we would have 0 holes, decimal point, 5 tenths, and 0 hundredths equals 50 hundredths. So C is also 50. What's the first place value to the right of the decimal or after the decimal? What do we call that? Say it again, Cash. Tenths. Tenths. What's the second place value past the decimal? What is it, Olivia?
100.
Hundredths. Very good. Tenths is the first place value past the decimal. Hundredths is next. What would be after hundredths? Thousandths. Very good. Then we would go 10 thousandths, 100 thousandths, and go on from there. All right. Number 4 is asking which problem is solved and modeled correctly. So let's look at option 1. We have 3/10. Does that show 3 of 10 spaces shaded?
Yes.
Okay. Is greater than 35 hundredths. Do I have 35 hundredths shaded?
Yes.
Yes, the shading is correct. What makes it incorrect?
That's bigger.
Yeah, it's saying that 3/10 is bigger, but that's not true, is it?
No.
We can see that 35 hundredths has 5 more pieces, more hundredths shaded. Okay? So if we look at option 2, 3/10, is it shaded correctly?
Yes.
Okay. Is less than 35 hundredths. Dylan, is 35 hundredths shaded correctly?
Yes.
Yes. Okay. So our shading is correct. Is 3/10 less than 35 hundredths?
Yes. Yes.
Yes, it is. Option 2 is your correct answer.
Question.
Yes, sir.
If that's hundreds, if those small ones are hundreds,
Mm-hmm.
wouldn't they be bigger because they're 100 to the other ones?
Okay. So that's a great question, Christopher. Christopher asked, if this is hundredths, wouldn't they be bigger? Look at the model. I have the same size hole. If I split it into 10 equal pieces, are those 10th size pieces bigger or smaller than if I split it into 100 equal size pieces?
Bigger.
The 10s are bigger, aren't they? Tenths.
Oh, that's
Tenths.
how you do it.
Yeah, it's like fractions. If I take it and split it into 10 pieces, those pieces are going to be larger than if I take the same amount and split it into 100 pieces.
Okay.
Okay? That was a very good question. Thank you for asking. All right. Last one, we've got to identify some fractions on this number line. All right. So we have a number line split up between 0 and 1. We're looking to see how many equal sized pieces there are. From 0 to the first mark is 1. Then we have 2, 3, 4, 5, 6, 7, 8 equal pieces. So our number line is broken into what size pieces?
8.
Eighths. So A, we could say, is how many eighths? 1/8. What would B be equal to? What is it, Cash? 2 what?
8.
2/8. Okay, then what would we have?
3.
3/8. And we could go on down, right? 3/8, 4/8, 5/8, 6/8, 7/8. There's not a box there at one hole, but how many eighths would that be? How many? I heard it.
8.
8/8. Very good. All right. So let's look for A. A is equal to 1/8. Do I have that option?
Yes.
Yes. So A, I should mark 1/8. Okay. B is 2/8.
But there's not a 2.
I don't have a 2/8 option. So I'm going to have to look for an equivalent fraction to 2/8. Okay. So I have the option of 1/2. Is B 1/2? I can look at 1/2 and see that that's not going to be, that B is not 1/2. Which one is 1/2? C. How do you know that, Harper?
Because it's 4/8.
Yeah, because it's 4/8. And if I just look at that, I can see that that's halfway. Very good. Okay, so I have 12ths and I have 8ths. We know, and 6ths. I know it's not 1/8, so let's try 12ths. Can I go from 8ths straight to 12ths? Is there anything I can multiply or divide 8 by to get 12? There's not anything, not any whole numbers, are there? So I'm going to have to go, let's see, let's look for a common factor between 2 and 8. What are the factors of 2?
1, 2, and 2.
1 and 2, right? That's it. So I could do 2 divided by 2. Can I do 8 divided by 2?
Yes.
Yes. So that would be 1/4. If I divide by 2 halves, that's going to equal 1/4. Is that an option? No. But could I go from 1/4 to 12? What can I do? 4 times what will get me 12?
3.
4 times 3 gets me 12, so I have to do 1 times 3 also.
So it'll be 3/12.
So it will be 3/12. Is that an option?
Yes.
So B is equal to 3/12. Okay, we already said C is 1/2. Okay, now we have D 6/8. We've got to figure out what that's going to be. So we already know I can divide 6/8. I can divide both of those by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So that's 3/4. Do I have an option of 3/4? Is that one of my choices?
No.
No. I need to get to 12ths. We already said up above that if we multiply 4 times 3, that gets us to 12.
1/12.
So 3 times 3 equals what?
1/12.
3 times 3?
Well, 1.
3 times 3?
1 times 3
9. 9. So 6/8
9/12.
is equal to 9/12. Is 9/12 one of my options?
Yes.
Yes. So D is 9/12. Questions about that one? It took a little bit of thinking to get to the equivalent fraction, but once we thought through it, it wasn't that bad, was it? All right.